3.2. So section, oops, 3.2, which was graphing linear equations in two variables. So just recall from last time, a linear equation in two variables is just an equation of the form, let's say ax plus by equaling c. And a solution to this is an ordered pair, such that if you replace every x by the first coordinate and y by the second coordinate, then this statement is a true statement. And so we graph some equations. Now let me suppose that we have some coordinate system. And suppose we have a curve relative to some coordinate system. Let's say something like that. Then, where this curve intersects the x-axis, this will be called the x-intercepts. So these are my x-intercepts. And where this curve intersects the y-axis, these will be called y-intercepts. Okay, so to find an x-intercept, you set y equal to 0 and you solve for x. To find a y-intercept, you set x equal to 0 and you solve for y. So note that the term x-intercept is the same as saying I have found the root of a polynomial which is also saying that I found the zero of a function. So the term x-intercept, root, 0 all mean the same thing. So let's do on page 112. Say problem number 22. In exercises 21 through 36, find the intercepts for each equation. So I have here 2x plus 3y equals 6. So let's set x equal to 0. Now let's do this. Let's find the x-intercept first. Let's set y equal to 0 and solve for x. 3 times 0 is 0. And so 2x plus 0 is just 2x. divide both sides of my equation by 2. So by the multiplicative property of equality, 6 divided by 2 is 3. So the x-intercept is the 0.30. Let's find the y-intercept. I can find the y-intercept by setting x equal to 0 and solving for y. 2 times 0 is 0. 0 plus 3y is just 3y. So again, solving for y, I can divide both sides of my equation. I can divide both sides of my equation by 3. And so by the multiplicative property of equality, have y is equal to 2. And so my y-intercept is 0, 2. Let me do problem number 28. 3x plus 2y equals 0. So let's first find, I guess, the x-intercept. Set y equal to 0 and solve for x. 2 times 0 is 0. 3x plus 0 is 3x. I can divide both sides of my equation by 3. So x is equal to 0. So therefore, my x-intercept is at the origin. I can find my y-intercept by setting x equal to 0 and solving for y. And so 3 times 0 is 0. 0 plus 2y is just 2y. So 2y is equal to 0. Let me solve for y. So by the multiplicative property of equality, I have y is equal to 0. Therefore, the y-intercept is at the origin. And so notice that in this particular case, both the x and y-intercepts are the same. It passes through the origin. Once it passes through the origin, both the x and y-intercepts will be the same. Question. So the only time actually the x and y-intercepts will be the same is when it when the curve passes through the origin. Okay. If the equal to 0, can't we just assume that? Oh, yes. So, yeah. So if you find that the x-intercept is 0, is at the origin, then you certainly know the y-intercept is also at the origin. And please note that for any x-intercept, y is always 0. For any y-intercept, x is also equal to 0. Yes, this is. This is section 3.2 that we're continuing on. Okay. So let's do problem number 32. X minus 2 equals 0. Okay, so let's find the x-intercept. Set y equal to 0. Solve for x. Well, there was no y, so I set all the available y's to 0. Let's solve for x. So by the additive property of equality, I can add 2 to both sides of my equation. So x is equal to 2. Therefore, the x-intercept is at 2, 0. Let's find the y-intercept. So let's set x equal to 0 and solve for y. Well, 0 minus 2 is a negative 2, but negative 2 is not equal to 0, so that's a contradiction. Therefore, the y-intercept does not exist. So there is no y-intercept. Okay, DNE means does not exist. That's what DNE means. Okay, so it could be that you have the same x and y intercepts when it passes the origin, or it could be that maybe either the x or maybe the y intercept doesn't exist. Okay. Let's do on page 113, let's do, let's say, problem number 38. X minus 2y equals 5. In exercises 37 through 60, graph the linear equation. Use intercepts whenever convenient. Okay, so let us try to find a table of values. So I'll just do a table of values and then try to plot the points, and then I'll draw a line through these 3 points. Again, you only need 2 points, but I'll do 3 just because I'll have one of them as being a check for the other one. Let me hopefully. Is everyone still able to see the right in the background, or did it disappear? Can you still see the right in the background? Yes, you can. Okay, good, good, good. Okay. So now what I have to do is I'm going to have to, good. I'm going to have to, everyone's good. Okay. I'm going to have to pick either X's or Y's so that I have points on the line. So I don't know. I can either do X's or Y's. I'll do Y's. And so let's do, let's say, negative 2, negative 1, and 0. Let's do those 3 points. And so let us try to determine x corresponding to those 3 different y's. So x minus 2, negative 2 equals 5. So x plus 4 equals 5. Subtract 4 from both sides. And so you get x equals 1. No, I don't pick random numbers. I pick numbers that are good. So I pick numbers. So how do you pick numbers? So you choose numbers um, where both coordinates are integer valued and they are neither too far nor too close to each other. So you have to pick points that you don't want points too close to each other nor too far from each other, and you want to pick points so that both the x and y coordinates are integer valued. Okay. Now, that's of course the problem with this technique. In order to figure all that out, you have to know what the graph looks like. So in order to graph it, you have to know what the graph looks like. In the next section, we'll give you an additional technique, differing techniques where you don't have to choose points, such as this. Okay, so x is 1. Let's do -1. And so I have here x minus 2 times -1 equals 5. So x plus 2 is 5. Subtract 2 from both sides of my equation. So by the additive property of equality, I have x is equal to 3. So 3, -1 is also a point on the line. And lastly, let's do y equals 0. So that's actually an x-intercept. X minus 2 times 0 is equal to 5. So x is equal to 5. And so now let's graph this. Again, what you have to do is, so one, you could pick 1, 2, 3, but those could be horrible numbers. The reason I didn't pick 1, 2, 3 is because then that is going to give you, you're going to be 11. So the y value would be 11. Oh, you're saying for x, pick 1, 2, 3. Oh, okay. So if you pick for x 1, 2, 3, then you're going to have a fraction. So I wouldn't want that. So then you're going to have fractions. So those would not certainly be good numbers to choose. Okay, so let's do this. So 1, 2, 4, 5. 2, 3, 4, 5. 2, 3, 4, 6, 7. Okay, so I'm here at 1, -2, at 3, -1. Wait, did I put in the wrong? 1, -2, 3, -1. Okay, and 5, 0. Okay, so if I look at that, see if I can draw this. And so I have the graph of x minus 2y equals 5. And that's what the graph looks like. Let's do another one. Let me do, let's say, problem number 52. 2x plus y equals 3. Let's draw that. Let me do a table of values. No, let's do -1, 0, 1. Nah, 0, 1, 2. Actually, even be better. So let's do that. And so, let's figure out if x is 0. What is y? Well, 2 times 0 is 0 plus y gives you y equals 3. Let's do 1. So I have 2 times 1 plus y equals 3. 2 times 1 is 2. Subtract 2 from both sides of my equation. So by the additive property of equality, I have y is equal to 1. And let's pick 2. So 2 times x, 2, plus y equals 3. 2 times 2 is 4, plus y equals 3. So by the additive property of equality, I can subtract 4 from both sides of my equation. And so I get y equals -1. And now let's draw this. Okay. So I'm just putting all my tick marks on the graph. Okay, so now let me plot the point 0, 3, the y-intercept, 1, 1, 2, -1. And now let's try to draw a line passing through those. If I can do that as best I can. Okay, so okay, good. So this is the graph of 2x plus y equals 3. Okay. Let's see. Maybe let's do problem number 60. No, how about 57? How about 57? 4x plus 3y equals 12. Okay, so let's do that. Okay, so how about 3, oops, 6. Oh, that'll be 0, 3, how about negative 3 gives you a still pretty big number. How about, okay, so 0, 3, 6. Let's do that. Those are still going to give you slightly big numbers, but not too bad. I mean, because negative 3 is still going to give you the same thing. Okay, so let's do this. So 4 times 0 plus 3y equals 12. So I get that 3y equals 12. Divide by 3. And so y is equal to 4. Um, right. I did the whole I computed them in my head. So I did the computations in my head to see if they were close or far away. So so I solved for x and y, and I went through a whole bunch of cases in my head, and these were basically the best numbers that I could come up with. Okay, so let's plug in 3. So I have 4 times 3 plus 3y equals 12. 4 times 3 is 12 plus 3y equals 12. So by additive property of quality, let's try to isolate y on one side of my equation. So let me subtract 12 from both sides of my equation. And so 3y equals 0. Divide both sides of my equation by 3. So y is equal to 0. Okay. Now let's pick x equals 6. So 6 times 4 is 24 plus 3y equals 12. Subtract 24 from both sides of your equation. And so 3y equals negative 12. Divide both sides of your equation by 3. So y equals negative 4. Okay. And so that's about as good as you can get, unfortunately, for integer values. Hmm. Okay. Let's see. 1, 2, 3, 4, 5, 7, 6. Okay, so let's see. Let's place the tick marks. Okay, so I'm here at 0, 4, the y-intercept. I am at 3, 0, x-intercept. And I am at 6, negative 4. So what you have to do, can you do the writing darker? Um, Can you do the writing darker? I don't think so. 1 second. That's a standard pen. It's black, so there's not a lot of choices. Let's see. Very. I can do a slightly bigger. So there, I can do it that. I can try that one. Well, but medium's going to be okay. I can do that. Okay, I have a slightly bigger point, not much bigger than that, or it'll be really difficult to see. Okay, so now let me draw a line connecting these 3 points. Mm. And that is the graph of 3x, no, 4x plus 3y equals 12. Okay? Okay. Um, so that's the graph of that. Um, the way I do it sort of in my head is I find a easy point on the equation. Like here, obviously 1, 1 is an easy solution to this. And then, let's say if I'm doing the x's, I know that if I have a 2 here, so the next x's will be up 2 and down 2. Or if I pick the x's, there's a 1 in front of the y, I know I can just go up or down 1. Similarly here, let's say 3, 0 is a solution to this. And then, if you want to figure out the x's, which is what I did, as I said, well, look, there's a 3 in front of the y, so subtract 3, add 3. Okay? And those will give you integer values. Actually, just about, for this one, these are really the only choices you could make for, to get integer values that are not too far from each other. Okay. Um, let's see. How about 59? So maybe I'll do one more of these. How about problem number 59? 5x minus 2y equals 10. So let's pick some points. So x, y. Obviously 2, 0 is a point on the line. So I'm really just going to pick a 2, 0 here. Okay. And so, unfortunately, this is really bad. This is a 5. So you have to go 5 away from the y's. So for the x's, and the x's, you're going to have to go 2 away. Okay, so 5. Let's do a 3. If you do a 7, that's going to give you... ooh. Oh, I'm sorry. X is 0. X is 2. Why did I say 5? 2. X is 2. So let's do 2, 0, and 4 will give you, or is it negative 2? Negative 2 may give you 20. Yeah, the 4 will give you Negative 4 is actually slightly better. So 0, 2, and 4. So now let's pick. So 5 times 0 minus 2y equals 10. So negative 2y equals 10. Divide by negative 2. So y equals negative 5. Let x equal 2. 5 times 2 is 10. So by the additive property of equality, I'll subtract 10 from both sides of my equation in order to isolate y on one side of my equation. So negative 2y equals 0. And so divide both sides of my equation by negative 2 in order to solve for y. So by the multiplicative property of equality, y is equal to 0. And lastly, let's plug in 4. 5 times 4 minus 2y is equal to 10. 5 times 4 is 20, minus 2y equals 10. Subtract 20 from both sides of my equation in order to isolate y on one side of my equation. And so by the added property of equality, negative 2y equals negative 10. Divide both sides of your equation by negative 2 in order to solve for y. So by the multiplicative property of equality, y is equal to a positive 5. Okay, and so now I can graph this. So unfortunately, these are just about the closest x's and y's you can get because you're multiplying by a 2 and a 5. So you know that the integer, once you find the integer values, the only integer values for x are going to be 2 apart from these. The only integer values for y are going to be 5 apart. So there's not a lot of choices here. You can only go a distance of 5 both above and below the y-intercept. Yeah. So it's again, it's because there's a 2 in front of the y. So that's why you have to go 2 from the x. Okay, so let's do this. Again, this is not the best technique. We'll be showing you a better technique um, in just a few minutes. Okay, so let's do this. X, Y. 4, 5, 1, 2, 3, 4. 5. 1, 2, 3, 4, 5. Okay, so let's see. Let's put the point 0, negative 5, 2, 0, 4, 5. Let's draw a line connecting these. And so that this is the graph of 5x minus 2y equals 10. Okay. Any questions about that? Okay, so that's basically how you can graph by choosing points. So this is one technique of graphing, is just to choose some points and then draw, to draw the curve passing through those points. The disadvantage of this is that you really have to know what the graph looks like in order to choose these points so that they're not too close to each other, not too far from each other, and that they'll always be integer valued. Okay, let me do, so that really finishes off section 3.2. Let's start section 3.3.